G'day everyone, and welcome to another episode of the vBrownBag podcast. Today we're joined by Matthew Meyer, talking about availability and resource management features which are new to vSphere 6.5. Just before we hand over and let Matt introduce himself, we'll just cover a few quick notes. So, if you want to follow anyone from vBrownBag through Twitter, we have a couple of different Twitter handles there, as you can see on the left-hand side, with our primary one being vBrownBag and a couple of regional ones below that. Also, we always use the hashtag vBrownBag, and we have a number of different podcasts, as you can see on the right. As I mentioned before, our guest today is Matt with his Twitter handle below, and I'm your host, Brett Johnson, and I'm on Twitter at BrettJohnson008. So if you're all ready, Matt, I will hand you over. I'll hand over a presentation to you for you to give us a rundown.
Sounds great. Thanks. All right. Here we go. Everything good? Can you see my screen okay?
Not just yet. It flicked up, but disappeared again.
Oh, here we go.
Right, now we're good.
Now we're good? Great. Well, thank you. Yeah, thanks for letting me join this evening or morning, wherever you're at. Again, I'm Matthew Meyer, work in the vSphere Technical Marketing Group here at VMware, focused on availability and resource management features, specifically around the new vSphere 6.5 launch that we launched just around VMworld Barcelona last year. And so I've got quite a few little topics to cover, so I'll just kind of dive right in here. The first is around vSphere HA and the proactive HA feature. And so what this does is it works in conjunction with our hardware OEM partners, and these are like the Dell, the HPs, and the Ciscos of the world. And what we do is we work with their hardware management platform monitoring system. And what it's doing is it's plugging into vCenter and notifying vCenter of any type of component failure that is, or an unhealthy component within each individual ESX host. And so for an example, there could be a fan that is not spinning at the proper RPMs, or it could be a network adapter that has failed for some reason. And when the partner's software management platform detects these type of failures, we can then take action before an actual impactful failure could occur. And so what we do is very simply is when we detect these type of failures coming from that management solution, we'll then just simply vMotion the virtual machines from the impacted host to a healthy host within the environment. By doing this, we introduce a new mode within vSphere. We call this quarantine mode. So similar to maintenance mode, where you would do an entire host evacuation of all of the VMs within that host, we now do them when we detect that there's a component failure. We'll do place the state of the host in quarantine mode. And when this is in quarantine mode, we will not place any new virtual machines on that host. And as long as there is sufficient capacity on the rest of the cluster, we'll go ahead and move all of the VMs off, or at least as much as we can before there is any type of performance impact on the cluster. And so the idea around this is that if you've got a imminent failure within the host that you think that is going to cause a host to go down, the best thing to do is to detect that early and get the virtual machines onto healthy host as quickly as possible, preventing any type of outage on the virtual machines. It is leveraging DRS to do any of these moves, so DRS is going to be a required feature that you'll have to have in addition to a vSphere HA, which is available on even the lowest SKUs. But to use this feature, you would have to use any of the additions that include vSphere DRS. In addition to that, a couple more details around this is that you can choose whether or not a different component is considered a moderate degradation or a severe degradation, and then you can choose how you want to respond to those different types of component failures. So if you think a fan failure, for example, is more of a moderate degradation where, hey, you know, it's not going to probably kill my machine, I don't necessarily need to evacuate the host. I can place that into more of a quarantine mode, so move them if I have sufficient capacity. But other types of failures you could deem a little bit more severe. So those types of failures can be placed into severe degradation or labeled severe degradation. And in that case, you can choose to completely evacuate the host, whether that by placing that into a full maintenance mode instead of just quarantine mode. Throwing a host in the maintenance mode is going to do exactly as you would always do for a maintenance mode operation. DRS comes in, makes its placement decisions for all of the virtual machines and completely evacuates that host. Back to that. It isn't going to, however, violate any of your business rules, DRS groups rules, affinity rules, any of those types of hard constraints that you've placed in the environment. We're not going to violate any of that whenever we do either a maintenance mode or a quarantine mode.
I've just got a question raised here.
Yeah.
Sorry, notice by Ken. What would happen should a host go into a quarantine mode to a moderate degradation and another host goes into a severe degradation? Basically, how would the VMs be able to, would the VMs go back to the moderate one to help unload the severe one?
Oh, yes. In that case, gosh, I've never tested that. I would have to assume that the severe degradation one would take priority. Anyone that's been placed into a maintenance mode based on the rule, I would assume that is how that is. I've never actually tested that, but that is how I would picture it working.
And one more question actually from myself. These rules where you can say, you know, a fan failure is puts it into a certain level of degradation, is that a cluster-based setting or can it be overwritten at the host level?
It is a cluster-based setting, and it is applied per type of failure in this case. And it's not necessarily down to each host level. It is only down to the cluster level. And what's interesting, though, is a lot of the times these management components do share a lot of things. And it's a lot of the times up to the vendor to decide whether or not a shared component would impact all of the hosts in that cluster or not. A good example is power supplies on a blade chassis system. If we detect that there's a power supply failure and all of the hosts in the cluster are sharing that same power supply, it doesn't make a lot of sense to place every host into into quarantine mode and moving all of the machines all over the place, because all the hosts would then be infected or affected by that component failure. So in that case, we wouldn't essentially be able to place all of the hosts into either a maintenance mode or a quarantine mode, and so it would at least be intelligent enough to detect those types of shared components in the blade chassis. But if we're using standalone rack mount servers, again, then it would kick in that case and move the machines around where you have the sufficient capacity. Configuring it is pretty straightforward. It's just a checkbox. The little information icon there. What that's showing you there is that you do need to enable DRS before you can enable proactive HA. And then the second step for this would be to install the web client plugin for whatever vendor that you're using for your hardware. And then this is where you go into the automation levels or the remediation, how we discussed, or how I discussed the different types of modes that you can place your hosts in as each failure is detected. And then you can, on the very bottom of that screen, you can override those as you want to, if you want to perform a certain action for a certain type of failure and override or take a certain, I guess, action based on a different certain component failure.
So I've got another question from Alex here. Should all our Dell VMs require being added to the OpenManage software, or does the OpenManage only need to be added to the host?
It is a host-based thing. So we'll receive the information from the Dell OpenManage as far as the host health and component health, and then we'll know which hosts are being impacted by that, and then by extension which VMs are on that host, and then make the intelligent placement decisions at that point to move the virtual machines to other hosts in the cluster. All right, moving on to restart priorities. Pretty simple, straightforward, and virtual vSphere 6.0 and before, we had 3 priority levels for vSphere HA. We had the high, the medium, and the low priority. These are different groups or priority levels whenever you had a host failure, how then capacity is being allocated to the rest of the cluster to restart the virtual machines. And so this is if you don't reserve enough capacity, you can dictate at least which virtual machines would come up first, and then it would then allocate the capacity for the next remaining priority level. So high being the first priority, and then after all the virtual machines for that priority level has been allocated its resources, it moves on to the medium priority, and then finally the lowest priority. In vSphere 6.5, we've introduced 2 more priority levels, so you'll have a little bit more control on how to group the virtual machines as far as capacity. We simply named this highest priority and lowest priority, and so it's configured exactly the same way as you did in previous versions. It's just that you have 2 more priority levels available to you. Extending on the priority levels, though, we have what we're calling the vSphere HA orchestrated restart. And this is similar to kind of a vApp within vSphere, how you had the ability to create startup order. And we're going to implement that same type of logic. The only difference is we're putting this on a cluster level, and you don't need to enable vApps in order to use this. Very common use case for this is a 3-tier app across multiple virtual machines, and if you did have a host failure, you want to ensure that you start those virtual machines in the order that it would need for the application to properly recover. And so in this case, if we lost this one host that happens to have all 3 of the tiers running on it, it would then restart the database server first. Once that has been successfully restarted, the app server will come up, and then subsequently the web server would come up after that. Whenever you're creating these different rules, the web client is going to detect and keep you from creating any type of conflicting rules, such as a circular dependency. If you had 2 VMs dependent on the same virtual machine, you can't create a conflicting dependency there, so it's going to detect those. And it's also going to ensure that you have the priorities, the priority groups defined correctly as well. So for example, you can't have, in this case, the database tier to be a medium priority and your app tier to be a high priority. It's going to detect that and prevent you from doing that. So the virtual machines that start up first have to be either in the same priority level or a higher priority level than the other virtual machines that are dependent upon that. And again, it's going to detect any of these rules for you or any violation of those rules before you're able to apply them. As far as how this is, how it's implemented in practice, we've got kind of an example here. We've got a free host cluster. And what I have here is a blue application that's running across 4 virtual machines. And then I have a red application that's running across a different set of those 4 virtual machines. And you can still run standalone virtual machines as well. They're just going to kind of jump around, and they're not going to be impacted by any of these dependency rules that we have here. And so for this case, I'm just going to create a simple dependency chain where VM2 is dependent on VM1, VM3 depending on 2, and then VM4 depending on 3, and that's the startup order that I would like to configure for that. And then the same for the red application, very similar startup dependency order there. And so if I lost the first host in this cluster, what would happen is that VM1 and VM8 would actually start at the same time. And the reason for this is VM1 is going to start up because it doesn't have anything that depends on it's waiting on to restart that virtual machine. It's not dependent on anything else, so it's going to start right away. VM8 doesn't also depend on, it depends on VM7, and that was already running on that third host, so it's going to immediately kick off and restart. And then once VM1 has finished its restart, or you can define it by a period of waiting between the restarting of the virtual machines, or you can detect that the application has started by either the VM tools or the application APIs that also work through the VMware tools to detect whether or not the dependency has successfully started before you kick off the next one in the chain. And so if you have VM1 that has started and everything is successful, VM2 is going to wait, and then it's going to restart after VM1 has finished. We reset that same example, and then we have the third host that fails. The dependency is going to be, or the restart is going to be a little bit different in this case. If you don't create any other rules, they're all going to restart at the same time. And again, this is because VM4 is depending on VM3, and that was already running on that second host. VM5 doesn't depend on anything, so it's going to restart again right away. But VM7 depends on VM6, and that's the only rule that was initially created here. And so since that rule was satisfied, it's also going to start at the same time. Now, the red application might have something in it that doesn't like that. If you restart that VM7 at the same time as VM5, it may completely avoid this entire process and the feature entirely. So it's very simple to get around that, and that's simply just create another rule set for VM7 to also depend on VM5. And so in that case, it will VM7 will pause and wait for VM5 to completely come up. It will then look to see that VM6 is up and running, so that dependency is satisfied, and then it would go ahead and restart VM7. As far as creating the different rules, it's a two-step process here. The first being the VM host groups, and so this is already something that you would create within the same way that you create like DRS groups and different rules like that. So the first thing you would create is the VM group, and you would apply the membership. And so in this case, we have different VM groups with only a member of a single VM. In this case, VM1, VM2, example, and so on. And then the second step is where you actually define those dependency rules. And so in this case, VM group number 1 is going, or VM2 rather, the VM group number 2 is going to depend on all the VMs that are started in VM group number 1. And so the rules, the dependency rules, are actually VM group to VM group rules, not individual VM to VM. And so that's why we've created in the prior step a group of a single VM. And then you would just create the simple dependency rules throughout here. So VM1 depending on VM2 depending on 1, VM3 on 2, VM4 on 3, and so on. And that's going to allow to restart those virtual machines in the proper order. I'm going to pause here and have any questions about that feature?
No, the questions are nice and clear at the moment.
Okay, good. Moving on to admission control. This is...
Oh, wait, hold on. Spoke too soon. Ken's come up. I have a question.
All right.
Sorry, Ken, if I missed that, I may have missed that question. Sorry, you can't type fast.
All right. I
did
not hear the question.
Yeah, here we go. Can VM3 depend on VM1 or VM2?
It's not an or, it's going to have to be an and in this case. But if that's something that yeah, I can definitely see how that would be something that could be useful, because you could have the same function residing on 2 VMs. So as long as one of them is up and running, it should be safe to start then the next virtual machine in the dependency chain. And so that is interesting. I'm going to pass that on to the product team, because that would be something that would be nice to have as an or within the VM group. So I would think that you could have a VM group that contains a couple of virtual machines, and then a rule that says, hey, as long as I got one of these up and running,
yeah.
Go ahead and
Ken's example there was domain controllers, and that's actually quite a good one, because if you're looking for like the DNS service, one of the two just needs to be up.
Right. That's actually quite good. Yeah, I'm going to pass that along. That's a really good question. So yeah, right now it is an and, like kind of a forced one-to-one dependency, not like anything that's super intelligent where it can do these, if, then, and ors or anything like that.
So internet high five for Ken, and no other questions.
Right. Okay. Moving on to admission control. So admission control is how we set aside capacity in a vSphere cluster. So if there is a failure that happens, you kind of ensure that you have sufficient capacity set aside for these virtual machines to restart. We've simplified the configuration, making this a little bit easier. By default, from version 6 to 6, and all the way back to the first version of vSphere, admission control has always been based on a number of hosts to fail, and then we do this whole slot size calculation thing. That was always the most conservative, in the fact that you would always reserve way too much capacity, and conservative being that you're going to get these virtual machines to restart, but at the same time you could be wasting capacity in order to have that reservation set aside. So what most of our customers would do in that case is that they would go in and they would just change the admission control policy to a percentage-based. What we're going to do, starting from vSphere 6.5 and all future versions, is we're changing the default policy from that slot-based policy to the percentage of cluster resources. But we're going to get the best of both worlds here, and we're going to ensure that, or require that you define a number of hosts that a cluster tolerates. And so by defining that number, if you wanted n+1 or n+2 or so on, you define that number, you change your policy to percentage of resources reserved, and then in the background, we calculate the number for you. So you no longer have to figure out what n+1 or n+2 is based on a percentage. You choose that as an integer on step 1 there, and then in the background, it's going to do all that math for you. If you add a host to a cluster, it automatically recalculates. If you remove a host from a cluster, again, automatically recalculates and changes the percentage that you need to satisfy that one host failing. It's also smart enough to detect worst case scenarios. So if you're running different sized hosts in the same cluster, by defining a value of 1, it's going to always choose the worst case scenario and choose the proper percentage to reserve based on the worst host, or the largest host in that cluster failing. The other thing is that we do offer the ability to override that. So you can get the former virtual vSphere functionality simply by choosing the override button and then forcing, or by a user definition, what the CPU and the memory percentage should be whenever you reserve that. So again, very simplified approach to this. You kind of get the best of both worlds now, where you're defining the number of hosts that you want to fail, reserve that, but we're reserving that now as a percentage of the resources reserved. So it's pretty sweet in that regard.
Okay, we've got got a question here from Kevin. Is it possible to get a vCPU to physical CPU ratio?
Yeah, and I'll cover that. Actually, that's a DRS setting that we have now applied. So we're going to enforce that using DRS, but we'll get to that here in a bit. On the percentage, this is just a couple of extra screenshots here to show what that would look like again. We have you define the number of failures that the cluster will tolerate. By default, it uses the percentage of resources reserved. We also can still do the slot-based policy. So you can choose, again, defining how many hosts that you would tolerate within the cluster, and then you can let it do its slot-based calculation. And again, you could go in and override that using a fixed slot-based size. Doesn't make a lot of sense, honestly, now that you have a fixed slot-based size, but we're kind of getting the best of both worlds. I don't see a lot of value in defining a fixed slot size anymore. If you, I guess, are thinking of a reason why you need to do that, I'd love to hear it, but I don't see a lot of value in doing the fixed slot-based size anymore, especially now that we automatically calculate the percentage. So that's kind of there for old or for upgrades, I think, and then, but I wouldn't see any new environment using that. And then finally, we have the dedicated failover host. That hasn't changed at all in any of the versions. What you're doing in this case is you're just setting aside one of the hosts that will be the recovery host. So if one of the hosts, any other hosts in the cluster were to fail, this is the one host that's going to bring all the virtual machines up. So it's got to tax that host depending on how many virtual machines failed. But one nice thing about that policy, though, is that you get a guaranteed amount of resources reserved for it. So if you wanted an n+1, you define the failover host, and you get the same performance after a failure as you did before the failure. So that's one really nice thing about the failover host policy that I think a lot of people kind of miss on that is that, yes, performance will be the same. Which actually brings us to the next thing here is what we're trying to address is when you do set aside resources using admission control to ensure that the reservations within the cluster are going to be satisfied after one of the hosts were to fail. But if you don't use reservations, you don't necessarily guarantee the same performance of the virtual machines after one or more of the hosts failed in the environment. It's always going to guarantee the resources are going to be there for anything that has a reservation. But if you don't use reservations again, if you've overcommitted your hosts, vSphere HA will still be able to power them on because there isn't a reservation for that. But if the consumed memory does exceed what the entire cluster can provide, you will see those memory reclaiming techniques that you have whenever you do over-allocate a cluster. So you could see, if you push it a little bit too far, you could see memory ballooning. You could see some swapping or compression in those cases. So just something to be aware of. And so what we're trying to do to make that a little bit more transparent so you don't have a performance problem after a vSphere HA event is we're allowing you to define a resource reduction event threshold. And so by default, it's set to 100%, which means it's the same as what it was in all previous versions of vSphere, meaning that it's not going to give you any type of warning or anything that your virtual machines could have impact to performance after a vSphere HA event. By changing this to, say, 0%, that is indicating that you want no performance penalty after you lost a host within the cluster that also is in line with how many host failures that the cluster tolerates. So for an example, if you have a 4-host cluster, you want to reserve an n+1 or n-1, so you would reserve 25%. Well, if you run all of your hosts at 75%, you're going to now have to move or have to restart all of the virtual machines from a host that was already running very hot. And so you're going to now overcommit the cluster, moving the virtual machines over from that failed host. And so in that case, you would have a reduction of performance. And so what we're going to show now is a warning on the vSphere web client. If we detect that just because you've set aside some capacity for vSphere HA, and it will go ahead and restart those virtual machines, you could impact the performance of those virtual machines after that restart. And so in version 6.5, we're going to display that as a warning message. And what we're looking at for future versions is try to come up with ways to apply admission control based on resource consumption and demand, rather than just based on what you've reserved for those resources. All right, jumping now into fault tolerance. Fault tolerance on 6.5 is got some improvements, especially around performance. There isn't any new features for fault tolerance with 6.5. So as far as like the feature itself has not changed. It's not going to do anything extra for you. There's no more than 4 virtual CPUs, for example, 64 gigs of memory. Everything's reserved. All the same requirements from version 6 apply to version 6.5. So you'll need that dedicated 10 gig link to do the fault tolerant logging, and you'll still need the shared storage for the primary VMX file and the tiebreaker files. The VMDK files can reside on dedicated storage, similar to how you could do that with vSphere 6. So that hasn't changed. However, we've made some functionality improvements where we now integrate better with DRS when doing FTVMs. And so it's going to now, when you enable FT on a virtual machine, it's going to reach out to DRS. It's going to ask it, okay, so where is the best place to put the secondary VM? It's also going to look at different things, especially around how much networking is available on the secondary host to ensure that you don't go, just by enabling FT, that you don't overrun one of the secondary host network. Another thing, it will prioritize the data stores. So it gives you a recommendation of where to put the secondary VM's VMDK file. And so what's different about vSphere 6 and 6.5's FT compared to version 5 is that we do make a whole secondary copy of all of the VMDK data on a secondary location. And so it's now at least giving you a recommendation of where you should put that, that data to ensure that it, A, is a separate data store from the primary, and then second, you have enough space on that secondary data store and give you the best place to put it. There's also been a lot of focus on performance between 6.5 and 6, though. And so they've gone through and they've done a lot of tuning on the network stack, as well as doing the primary and the secondary host communication has been improved quite a bit. And so we're seeing drastic improvements between even 6 to 6.5. And then we applied those same fixes that we did for the 6.5 launch. We applied those backward compatible to 6.0 update 3. So anything that you can do in 6.5, as long as you've upgraded your ESX hosts to 6.0 update 3, you'll get those same improvements. What we were seeing is that in the initial launch of 6.0, FTVMs would suffer a little bit of extra latency between the primary and the secondary, and in some latency-sensitive VMs or applications within those VMs, it could, even the additional overhead of that latency did impact those applications. And so what we've done is we've really tuned that quite a bit to reduce the latency as much as possible between the primary and the secondary. And by reducing that latency, it increased the performance within the virtual machine. And then the final thing that we're doing is just like you can do a multi-NIC vMotion, where you create two separate VM kernel port groups and then create a physical NIC, or you bind a physical NIC to that port group, you can do the same now with FT. So it will essentially bond these multiple PNICs to create an increased virtual network channel. So you can get those additional lanes of communication between the primary and the secondary host, giving you even more capability within FTVMs that are producing a lot of bandwidth and a lot of network traffic. You can essentially create these additional lanes. So if you don't have 40 gig networking or 100 gig networking, you can bind multiple 10 gigs together and get the same benefit from that. All right, jumping into DRS. A couple of advanced features that we've now brought over from what used to be advanced settings in the product through an advanced setting that you would have to apply manually. We're now just bringing those over to a UI, so simple, easy to do checkbox, and it applies to the whole cluster. The first being an even distribution of the virtual machines. DRS, first and foremost, will always load balance, do initial placement, or anything based on utilization of the compute resources. It doesn't care that you've got 20 virtual machines on one host and 60 on another. As long as the VMs are getting the resources that they need, everybody's happy. So that's not its primary intention. By enabling this feature, it does allow you to avoid putting all those eggs in one basket, and so it will do a more even distribution of the VM count on the hosts within the cluster. And so if you do lose one host, you kind of have an idea of the impact of how many virtual machines you would lose from that one host. And then secondary to that, it would balance based on the utilization or the consumption rate of the resources. If for some reason, though, that the virtual machines are not getting what they need on one particular host, and you have this enabled, it will violate the even distribution for the ability to get the best performance out of the virtual machines. So just something to know that it is going to work in most cases, but it will violate that if it needs to under certain conditions. The second that we brought over is load balance based on consumed memory instead of active memory. And so one interesting thing about DRS is that one of the biggest, things of confusion, what most vSphere admins will do is they'll look at their vSphere web client, and they'll look at the host tab, and they'll look at the memory consumed. And they'll notice a lot of times that they're not in balance. And we'll get a lot of questions about, well, why is DRS not moving my virtual machines to keep my cluster in balance, even though I've told it, I've changed the migration threshold very high, or I'm not seeing any virtual machines or move around. And the biggest reason for that is DRS is using the active memory of the host plus a 25% buffer. And what people are looking at in the vSphere web client is actually consumed memory. So it's two different memory metrics that are being used to make placement decisions. And so if you're not over-allocating memory, it doesn't hurt to use the consumed memory metric instead of the active memory metric. And so the idea around that is that if you're not over-committing memory, you can in previous versions, you would just set this advanced setting for % idle VM in mem demand to 100%, which would effectively cause DRS to use the consumed memory metric instead of active, and then it would rebalance the host based on that consumed memory, which also then happens to be the same memory metric that you see in the web client. So just by clicking the box, a lot of customers are going to see a more even distribution of memory resources, but it may or may not necessarily mean the performance is any better. It's just that you're going to see a prettier UI. Your cluster is going to look a lot more balanced. And then last, what we've done is provided a way to implement a virtual CPU to physical CPU overcommit ratio at a cluster level. So this goes back to that question that we had earlier. Is there a way to define that? And this is how you would do that, is if you want to ensure that you don't overcommit a cluster, and then by extension even a host, you would implement this, checkbox, which would keep virtual machines virtual machines from being created and then powered on a cluster that you define a certain overcommit ratio ceiling. And so a good use case for this is VDI environments, where you may have certain situations where peaks and valleys of performance. So at the beginning of the day, a lot of people are coming in, they're logging in for the first time, then their applications are running, they're idle, and you might see a dip, but you need to plan for that peak. And so just because the average utilization over that cluster is moderate to low, you don't want to overcommit the cluster. And so you want to define some kind of a policy that ensures that you don't do that. And so this is what's preventing any type of overcommitment of the virtual CPUs in the cluster. And then finally, we have the network-aware DRS. And so this is a little different than network DRS. It's not going to rebalance hosts within a cluster simply based on network load. Instead, we're still going to base everything based on CPU and memory load as far as the compute resources. However, we are going to make one more additional check for DRS to do before it places a virtual machine on another host. And it's going to then look now at the utilization rate of the physical NICs on each host. And so if for some reason a virtual machine is running a little hot on one host and it's not getting the resources that it needs, DRS will come in and make a new placement decision for that virtual machine. And in prior versions, it did not ever look at the network utilization rates on all the other hosts in the cluster. And so if a host is already network saturated, and what we mean by that is any host that is over 80% utilized, DRS will no longer use that host for a placement of a virtual machine. It will then move to the next host in line for placement decisions. So we're just trying to over subscribe the links and make better placement decisions for DRS. So it's not network DRS where it's balancing virtual machines strictly based on network load. It's still using CPU and memory, but it's one additional check that it does in its workflow when doing placement decisions. And the same thing happens again also with any type of placement decision. So it could be due to a affinity rule. It could be due to a host going into maintenance mode. Anything it's going to do is going to make that additional check, and then it's going to, the idea is to avoid a problem that is related to network saturation. All right, that is the end of the slide deck I had. If there's any questions, I'd be glad to answer those as we close this out.
At the moment, questions are looking quiet. We'll just give it a second, see if anyone pipes up with anything. I think we're looking done. So thank you very much for that, Matt. It was definitely very insightful and a lot of tips that we'll probably many of us will end up using on our day-to-day administration of a vSphere infrastructure.
Oh, thanks. Yeah.
So thank you everyone for attending, and this has been another podcast for vBrownBag. Oh wait, hold on. Maybe.
Oh, okay. Yeah.
Oh wait, nope. I enjoyed this webinar very much. No questions. There we go. So you go. Thanks.
Okay. Well, great. Yeah, it's been a pleasure. I appreciate the opportunity. I'll let you guys get back to it. Thanks.
Thank you everyone for attending, and thank you once again, Matt, for presenting.